section 10.5, which is the binomial theorem. I'm going to try to post a PDF file of the handout, but you may also pick up a copy in the classroom by Monday. So what we're going to do here, the section is not very long, and it's going to build up so that we could study the next two sections, 10.6 and 10.7. So what we have here is the binomial theorem, and that is the title of the section. But before we get to the binomial theorem, we're going to go over the definition and apply it of the binomial coefficient. So it says here that for non-negative integers n, remember that means all positive and also including n equals 0, right? And positive integers. And r, so they're both integers, and we have that n is always going to be greater than r. So the number that will be on top, that will always be greater. So the expression n and r, and it is read n above r, you may also say n items choose r at a time. What I mean by that, imagine that you have a container, and that container has, let's say, 4, 5, 6, 7 marbles. And so you could say, well, some of them are blue, and then the other ones maybe green, and then the other ones are red. So if we wanted to know, for example, and how many ways could you choose one of those marbles and just get a red one, then you will say something like, out of 3, I'm going to choose 1. Okay? So that is just one of the applications to it. But before we get to those, we're just going to learn how to do it by hand, and then I'll show you with the calculator. So now, the reason you can have the number on the bottom must be smaller is because for the red marbles, we could ask out of 3, how many ways can you get 1 or 2 or get 3? And that's them saying that like if you were choosing 2 at a time or something like that. Now here, what we're going to do is use the factorial operations that we study in section 10.1, I think. And once we get to section 10.6, we're actually going to refer to this operation with a different name, but I will save that one for later. Okay? But I will remind you. So let's just evaluate the following by using the binomial coefficient formula. So right here, if we have 6 things and we choose 2 at a time, and how many different ways can we choose them? Let me show you this. So let's say that you have, and let's just assign letters, A, B, C, D, E, F. So we have 6 poles, and we're going to choose 2 at a time. So how many different ways can you get them? Okay. So let's use the formula. So we'll have 6 choose 2. It will be 6 factorial over 2 factorial for r. And then we need the difference between n and r, 6 minus 2, and then factorial. So here, this will be 6 factorial, 2 factorial, 4 factorial. And we know that 6 factorial could be written as 4 factorial, but we still need to multiply times 5 times 6. Do you guys remember that? And on the bottom, we have 2 factorial, and we have 4 factorial. So here, we know 4 factorial divided by 4 factorial is equal to 1. So we say they cancel. And here, we will have 30 divided by 2, which is 15. So So what that means, based on my example that I gave you, is that you could get A and B, or you could get A and C, or you could get A and B, you could get A and E, or you could get B and C, B and D, B and E. Oh, I even forgot about F. So I could keep going like that and come up with the 15 different combinations. Okay, so that's what we're going to use it. Since I already used the word combination, let's just throw it in there. That is actually what it means. And in the next section, we're going to look at something called combinations, which is the same thing that you see here. And the other thing will be called permutations. All right, so right now let's just take it one step at a time, and let's just finish solving B, C, and D by using the formula or the binomial coefficient. So part B, n is 3, r is 0, so it will be 3 factorial divided by 0 factorial, and then the difference, 3 minus 0, factorial. Do you guys remember what is 0 factorial? 1. And so this one is just 1. And so it kind of makes sense if you think about it, and you had 3 balls, and they're A, B, C. In how many ways can you choose 0? Just one way. Nothing, right? So yes, that's correct. Now let's look at 9, choose 3. I want you guys to try that one on your own. And then just go ahead and try D. We have with 56 cents. 504. Thank you. 500.
Oh, 504.
And 4. And then divided by 6?
Yes. And that's 84.
84. Thanks. And then for D, do you guys get a 1?
Yes.
Yes? Okay. And it makes sense. Think about you have something with 4 marbles, balls, and you're going to pick up 4. So how many ways can you get all 4? Just one way, right?
No.
Yeah. So 4 factorial over 4 factorial, 4 minus 4, 4 factorial, 4 factorial, 0 factorial. 1 over 1, which is 1. Okay, let's move on to the next slide. Now, how can we apply the binomial coefficient? Well, the binomial coefficient, it is used every time you expand something. So, for example, if you were to expand the binomial here, it's just to the power 1, so it would just be A plus B. I could just rewrite it without parentheses, and that's the answer. For the next one, we will have A plus B times A plus B, and then it will be A squared plus 2AB plus B squared. Now, for the next one, this is A plus B a plus b times a plus b. So in this case, you will have to multiply a plus b. If I use the associative property, I can get those two. I already have the answer for that. And then I will have to multiply, right? And that could be a little time consuming. So what we do is you could get the binomial coefficients for each single term. Now I'm going to save myself some time and get all the answers there so you can copy them. So those are the binomial expansions for a plus b to the power 1, to the power 2, to the power 3, to the power 4, and to the power 5. And so after you copy them, I'm going to tell you where these little numbers are coming from. So I'm going to start reading the statements on the bottom as you keep writing. So the first term in the expansion, and here we're saying the exponent is just n to generalize it. It will be a to the power n, and that is true for all of them. If you notice, a plus b squared, the first term is a squared. Here, the first term is a cubed, a fourth, a fifth. Now, after we get that out of the way, the exponents of a decrease by 1 at a time. And notice here, we have a to the fifth, we have a to the fourth, a to the third, a to the second, a to the 1, and even here we have a to the 0, right? Okay. Now, if we look at the exponents on b, they also, well, not also, but they increase by 1 in each successive term. So one after the other. And the very first one is going to be b to the power 0. So if you notice here, we have b to the power 0, but then the exponents for b are increasing by 1. So here we have b to the power 1, b to the power 2, b to the power 3, b to the power 4, and then b to the power 5. Okay? Did you guys get it? It's like a little pattern. So the exponents for the first term are going to start with a 5 and then decrease. The exponents for b are going to start with a 0 and then increase. Now, what is the binomial coefficient? Well, the binomial coefficient are all those numbers that I have traced with blue. And where are all those numbers coming from? Well, they're coming from here. Right here, we could start with 2. Two, 0, 2, 1, and 2, 2. I'm not so sure if 2, 0 is first or 2, 2. Let me check. Let me see it. Oh, yes, we start with a 0. So, for these numbers here, these coefficients that you see here, this 1 came from 2, choose 0. This 2 came from 2, choose 1. And this 1 came from 2, choose 2. So that's where the binomial coefficient will help us out. That one, it's not listed here, but it is on the next slide. Now, what you see here is that anytime you add the exponents of the A term and the B term, they're always going to add to what, guys? Let's see here. What is 5 plus 0? 5. What is 4 plus 1?
5.
What is 3 plus 2?
5.
2 plus 3?
5.
1 plus 4?
5.
And 5 plus 0? 5. You see? So every term will be of degree 5. Okay? Now, the numbers of the terms in the polynomial expansion is 1 greater than the power of the binomial. So for example, if we have something to the second power, how many terms do we have? 1, 2, 3. We have something to the third power, how many terms do we have? 4. Fourth power, 5 terms, and so on. Okay? So that's what the very last statement means. That you will always have n plus 1 number of terms. Okay? Now, there's a very easy and actually pretty cool way to get those coefficients. And that one will be the Pascal's triangle. Now, you already have it here, so you don't need to take notes. I just want to show you how to construct it on your own. Okay? So, you start with a 1, and then you're going to make like a triangle. That's where the Pascal's triangle comes from, right? And so, we have 1, and then we're always going to have 1 at the end. And it kind of starts looking like a quinceañera cake, a little bit, with the candles. Okay? Now, what do we get if I was to add 1 plus 1? 2. Now, next row again, 1 and 1. And then, what do I get if I add 1 plus 2?
3.
How about 2 plus 1? 3. Let's do 1 and 1 more. 1 and 1. And then we have 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And can you guys do the next row? Okay, so Cassandra?
5.
Okay. Jennifer?
10.
Ruben? Timmy?
5.
Okay. And then the next row, Janine?
6.
Jesus?
15.
Brisa?
20.
And Yvette?
15.
And Brandon?
6.
6. Very good. So if you notice, you see how quickly we did all that? We were doing all those binomial coefficients. And right here, this one goes all the way to this one right here. What power will that be? This will be the coefficients of something like AB squared, AB cubed, AB to the 4th. So this one will be what?
To the 8th power.
To the 8th power. Okay, so if we were to expand that one, look how quickly I could do it. A to the 8th power. The next one will have this number for the coefficient. The A power will decrease by 1.
7.
And then the B power will increase by 1. Here it was B to the 0, so here's 1. And then the next one I will use 28. A to the 6, B to the 2. So the A powers are decreasing, B powers are increasing by 1. The next one, the coefficient is 56. A to the 5th, B to the 3rd. And then plus 7. A to the 4th, B to the 4th. And the next one will be plus 56, A to the 3rd, B to the 5th. And remember, every time you add the powers of each term, they should add up to 8. Okay? So the next one, what will be the next one, Brandon?
28. A. Or 2. And then B 6.
Correct. And then we have plus 8. And Jesus, what would that be?
A 1.
Uh-huh.
be 7.
7. And the very last one is just going to be a coefficient 1, and it will be a to the power 0, which we just don't write it. So b to the 8. So you guys see how quickly you can do that? Yes.
If instead of a plus b, it was a minus b, what sign change?
Yes. And actually, that's what, let's start doing some of those. Yes. That actually has a lot to do, and so yes, we have to be careful. How about you guys do that one? Try to do that one on your own. And then I will walk you guys through the next one, because it does have that negative. And you could use your Pascal's triangle. I'm okay with that. You don't have to do the binomial coefficient all the time. For this example, we're going to use the Pascal's triangle. So if we go to the slide towards the end, we're going to be using this row right here. So we have 1, 4, 6, 4, 1. And so right here, instead of using a and b, we're using x and 2. So the first one will be x to the power 4, 2 to the power 0.
Bless you.
Bless you. Thank you. X to the power 3. And then we'll have 2 to what power, guys? 1. So remember, 2, although it doesn't have a variable, is still a term. So remember, the x powers decrease by 1, and the 2 powers increase by 1. And of course, if your terms are numbers, we still need to simplify it. So here we have 4 times 2 times x cubed. Here I will have 6 times 4 because we have 2 squared, x squared. And then 4 times 2 cubed is 8. You still have that x. And the last one will be 2 to the power 4 is 16. Then we still need to simplify a little bit more because right here we can multiply, and multiply here. So the final answer will be x to the 4 plus 8 x cubed plus 24 x squared plus 32 x plus 16. Is there any step, any term that you would like me to clarify, correct, rephrase? Okay, so are you guys ready for the one with negative? Okay. So what should we do anytime what do I tell you to do when you have negatives, besides being careful? I tell you to use what?
Our brain.
Yes. Something else. We look like this. Yes. So that's going to be the key here. So let's get the coefficients. You can use the Pascal's triangle. So we have, I know the first one is a 1 and a 5. And then? Okay. Okay. So those are going to be our coefficients. So let's start with that. So we will have 1, and then 5. Let's just leave some room for us. 10, 10, 5, and 1. And then we're going to take care of the 2x. And it's together, so we're going to need parentheses there, okay? 2x to the power 5 And in this case, we will have negative y to the power 0. Well, let's take care of all the 2x first. So right here, we will have plus, oh, sorry, not plus, but times 2x to the power 4, and then here we have 2x to the power 3, 2x to the power 2, 2x to the power 1, and 2x to the power 0. Now let's take care about that negative y, and of that negative y. So negative y to the power 0, negative y to the power 1, negative y to the power 2, negative y to the power 3, negative y to the power 4, and negative y to the power 5. Now let's start simplifying. So here, when we have 2x to the power 5, keep in mind that we're saying 2 to the power 5 and also x to the power 5. All right? Are we okay with that? So in this case, we're saying 2 to the power 5 is 32. So that's 32x to the power 5. What happens with the negative y to the power 0? That's just equal to 1, right? So the next term will be, you can look at your signs, and we have a positive and we have a negative here. But actually, let's not worry about the signs yet. So let's use the 5. And then what is 2 to the power 4? This 2 to the power 4, that will be 16 x to the power 4. And then here we have negative 1. Let's just say negative 1. Then the next term, we have the binomial coefficient of 10. And then we have here 2x to the power 3. So remember that is 2 to the power 3 and x to the power 3. So that will be 8x cubed. And then right here we have a negative y squared. So what happens when you have a negative term and then you square it? It's positive, so that would be positive y squared. Then next one, we have a 10, 2x squared, that will be 4x squared. Negative y to the power 3, that will be negative y to the power 3. Next term, we will have a 5, we will have a 2x, and then here we have negative y, but we're raising it to an even power, so that will make it positive, so positive y to the 4. And the very last term is very easy because 2 to the x is just 1 times 1, 4 is 1, and then negative y to the power 5 will be positive or negative? Negative. Okay, so let's just finish clearing this up. So that will be 32x to the power 5. Will we have a positive or negative sign? Negative, because we have the positive and the negative from here. So that will be minus 5 times 16, that will be 80. So 80x to the power 4y. The next term is going to be positive. We have 10 times 8, so that would be 80 x cubed y squared. The next one will be positive or negative? Negative, right? We have this negative and positive here. That will be minus 10, not 10, 40, because I'm multiplying 10 times 4, x to the power 3, y to the power 3. I'm sorry, x to the power 2. How did I catch my mistake before you call it out?
It didn't equal to 5.
They didn't equal to 5. Exactly. So right here, the next one will be 5 times 2 is 10, x, y to the power 4, and the very last one is minus y to the power 5. Okay. So let's move on. Did you guys copy the whole thing? Yes? Anyone who's still writing? No? Okay. Great. Okay, so let's see, what do we have here? So finding a particular term in the binomial expansion. So now, instead of doing the whole thing, let's just find one term. So in this case, it says for us to find the fourth term. And we're raising something here to the 7th power. Could you guys tell me the coefficients for the Pascal's triangle for that row?
1, 7, 21, 35, 35, 21, 7, 1.
And you guys notice how they're symmetric?
Yeah.
Yeah? So the 4th term is going to have this coefficient, 35. Using this formula, we should be saying something like 7, choose 3. But we don't need to do that. We could just use Pascal's triangle. So we know we're going to get a 35. And then our first term, which is 3x, will be raised to what power, guys? So think about it. We're doing this. We have 7. We're going to choose the 3rd term. They go in this order. These numbers come from here. 7, choose 0. 7, choose 1. 7, choose 2. According. So the coefficients come from here, and if we want the 4th term, we're going to have to go, this is like the 4th term, so that's why R is a 3. That's why I'm using a 3 for R, okay? So right here, if I apply the formula, it should be something like 3x, the first term, to the power n minus r. So that will be to the power 7 minus 3, which is 4. And then the next term that we have here is 2y. So it will be 2y to the third, yes. How do you know so quickly?
Because 7 minus 4 is 3, and then you
Add up to 7. Very nice. And also we have, because here we have that r, which is 2. So we do that. Let's finish this one quickly. So we'll have 35. 3 to the power 4. This one, right? Okay, thank you. So what is 3 to the power 4, guys? Is that 81? 81x to the 4th. And then this should be a 3. So that will be times 8y cubed. And then we're going to need someone with a calculator to do this quickly for us. 35 times 81 times 8. Okay, tell me digit by digit. 8, 0. Okay, so that will be our big coefficient, x to the power 4, y to the power 3. So this will be the last video, but I'm going to record the last 2 slides. Oh, actually, we're done. We're done. Great.